Okay, welcome back. So in the last video we did talk about control statements and we checked if statement. So far at this point we have learned that all statements end with a semicolon, but the compound statement is an exception to this law. This rule, because a compound statement is equivalent to a single statement. So this means that you can place a compound statement where a single statement is allowed. For example, let's create an example here. Call it example number 1, and that's it. So include std.h into main, then what do so let's declare one variable integer k, give it a value 100, then say print f. This one is a single statement, so I am a single statement. Then let's create a block and say this one, let me comment, this is a compound statement. Print f1, I am inside a compound statement. Create an me copy and paste it. And say another statement, and inside a compound statement. So after all that, we get out of our compound statement and return 0. This we say that it's like a signal to the operating system that everything worked fine. So if everything worked fine, return a 0 to the operating system. So let's compile this one and run it. Let me open a new terminal. CD. Control statement and GCC -0 example1 example1.c and run it example1.x. Okay, there is an error. I'm used to Linux, so I thought I could combine those two commands as a sentence, but it's unfortunate, so I have to call them one by one. So example, you see, I'm a single statement. It did learn fine. So basically a compound statement is a block of statements inside braces. So that is a compound statement. Something else we did in that other video, we looked at an example of an if statement. and we saw that if statement is used to test a condition and take one of the two possible actions. So let's look at the syntax. If statement. Let's look at the syntax of this if statement. Include stdio.h. So the syntax of an if statement is if, then have condition. If condition is true, then this is an if block. Then here we can have statement 1, semicolon, tuk, up to statement n. This means if the condition in this, if this condition is true, then go ahead and perform these statements, execute the statements. If it is not true and you want to do something else, then we use else. So this else can have a condition, else do something, statement 1, etc. But you cannot use else condition. Else takes no like there's no condition. This is the opposite. If this is not true, meaning if it is not true, it is false. So this automatically is the opposite of this. But if you want to test another condition, you must use else if, then condition. Else if condition. For example, let's say we are writing a program to check the greatest number among 3. So we have different ifs. The first if check, let's say we say we have 3 numbers. Number 1 is A, number 2 is B, number 3 is C. First we check if number 1 is greater than number 2. If A is greater than B. If it is greater than B, good. If it is true, then we check if A is greater than C. So if A is greater than C, and we already saw that it's greater than B, then we satisfy that A is the greatest among the 3. Else if A was not greater than B, then we check B if B is greater than C. So we have different ifs. So we have to use else if. But if we are checking 2 numbers, the greatest number among 2, we just need if and else. There's no else if. For example, if this condition, if 1 is less than 2, that is mean it's true, less than 2, do that. Else if it is not true, let's get rid of this. If it is not true, do perform this statement. So that is it, part 2 of if statement. So let's check an example of an if, another example of an if statement. And in this case we check if number given is even. So let's call it check even. Let's see. So a program to check whether a number provided is even. So include stdio.h int main. So Let's declare one variable and call it number. Then let's ask the user to enter a number or a digit. So let's scan this digit, scan F, percentage D. Oops, forgot to put it in there. So M number. So let's check if okay, we are checking whether this number is an even or not. So we must understand first how even numbers behave. So, and in this case we know that even numbers are numbers that they are divisible by 2. If we divide that number by 2, we get no remainder. So our logic here is to check if we divide that number by 2, the remainder is 0. If it is 0, then that number it's even. I hope we are together up to that point. For example, if we have a number, our user entered number 5. We divide 5 by 2, you'll get 2 remainder 1. So the remainder here is not equal to 0. If our number was 4, we divide that number by 2, we get 2 remainder 0. So our logic is here. So check if number divided by 2, the remainder is 0. If it is 0, then print number. Oh, sorry. Percentage D is even. Then formatting number. I used N here, sorry, it's number, not M. Remember what we said, if the statement inside this condition is one statement, we don't need to use the braces. But if there were there were many, there must be need to include those braces, because by default it checks if there are no braces, it assumes that only one statement. So after checking that one and printing it, let's return 0. It's a signal to the operating system that everything went fine. Return 0. So let's compile and run this one. So gcc-o output check even, not C. No error, so check even. So enter digit. Let me take 5. Okay, 5. In this case 5 is not even, so we didn't use an else. So let's check 4. So okay, sorry, check even, enter digit 4. 4 is even. Let's include an else so that the user can know if it is not even. Else, let's print F percentage D. It's not even. Let's save it. Let's compare it. Run it. So enter digit 10. 10 is even. Enter digit 9. 9 is not even. So I think to that point we understand the basics of an if else control a statement. So do more practice. Have a good time.